Okay, so let's continue now with an exercise. How can we apply what we just learned, that risk and inflation can determine the price of an exchange rate? So the name of this theory is called the theory of interest rate parity. It is also called the Fisher effect in simple terms. And as every theory, this theory has its assumptions that sometimes complicate things because assumptions sometimes are not true in real life. So the assumption in this theory is that first, we have efficient markets, which usually that doesn't work. Then we have no transaction cost. Usually that sometimes doesn't work. And that also the interest rate should actually reflect the risk and the inflation rate of the country. So this theory lies on the assumption that the interest rate reflects all the risk in the country. And this is where it's its biggest failure, I will say. It's a Nobel Prize winning theory. It's someone won 1 million Swiss francs from this, but it's still not perfect because I mean, like it's impossible to find a perfect theory. But if we analyze this part where we assume that the interest rate actually reflects in perfection the risk and inflation of a country, I think that's something that it's impossible to happen. In the last semester, I was talking about this with other students, and we come to the conclusion, which is quite funny. Like if you define the interest rate by the end of the year for the next year, you don't know what will happen. And we just experienced that, right? When we started 2020, we didn't know that this thing with the virus will be so huge. So who will be able to give a proper or correct interest rate for the year 2020? So it's very difficult for that to happen. But in the end, it's the best theory that we have so far. So we are going to keep using this. Also, kind of a joke from the last semester, we learned that assuming this is like when you want to get married, at the moment that you are in the church saying that you accept to get married, you can say, yes, I accept, but only for today. For tomorrow, I don't know. Why? Because things can change, right? So it's kind of the same thing. Like we are assuming that the interest rate that we have right now is going to perfectly reflect the risk and the inflation of the country over the years, which usually doesn't work. But anyway, this is one of the best theories that we have so far. It's important that we know about it, and we are going to do some exercise with this. So let me show you the formula that we are going to use, because it's a little bit different to what we were doing in the other in the last week when we used another formula. The other formula was the relative PPP formula, and this formula is called the forward formula. So the formula is over here in the presentation. So you have here we want to calculate the forward rate of the Swiss franc over dollars in 6 months, right? So that's what we want to calculate. And we have the spot rate. The spot rate means today. And what we are going to do is to multiply that times the difference of interest rates. How does this work? Well, it is 1 plus, we have the interest rate of Switzerland. Why Switzerland first? Because we have Switzerland on top. That's why top and top. So this is home and this is home. And then this is a bit different to what we had in the previous formula. And this is only something that our book assumed. Because if you read another book, or if you use another book in another class, like I think in derivatives, maybe it can change a little bit. But in our book, we are going to use time in days. So like in here, if I say 6 months, it's going to be 180. Do you remember from in the other formula? It was per years, right? So if we refer to 6 months, it will be 0.5. Well, here it's different. Here is in days. And then that is divided over 360. Why 360? Because 360 is the financial year. Why did they assume 360 days in a year? Well, because of two reasons. The first one is that apparently the average number of holidays in the world is 5. So if you subtract the 5 holidays, then you have 360 days in the year. But also the other reason is just because it's more practical to use 360 instead of 365. So that's basically the formula. You have the number of days divided over 360, and at the bottom you have exactly the same thing, but with the interest rate of the foreign country, in this case the US. So I prepared a very short problem in Excel that we can solve in here. So before we do the problem, let me tell you the things that are going to change. The first one is that the interest rate is going to be the nominal interest rate. Previously, on the relative PPP formula, it was the inflation rate. In here is different, right? So it's interest rate, nominal interest rate. Then time will be in days, not in years as previously. And finally, the capitalization of interest in here are simple. That's why we are going to use the 1/360. Sorry, the time over 360, right? That's simple compound. It's not like in the other formula when we have it squared. Like, you remember that time was an exponent. So be careful with that. Those are the three differences that you should know about. So this is the data that I have for this problem. So the spot is 20 pesos per dollar. That's the spot of today. Then we have the interest rate of the US, which is 3%. And here it says PA. PA means per annum. So it's the annual rate. So it's just a formality. Then we have the interest rate of Mexico, 5%. And then we have time. We want to calculate the forward price in 90 days. So let's do the formula over here. So first we're going to use spot as we had in our formula. It's going to be spot 20 times, and then we are going to do the upper side of the formula, which is 1 plus the interest rate of the local country. So in here, local country is Mexico, home country, because we have Mexico on top. So Mexico, 0.03 times time, 90 over 360. And then you close the parentheses. Be very careful when you use your calculator. Like, first do whatever you have inside of the parentheses and then add the 1. If you do 1 times 0.03, then you're messing up everything. Be very careful. Here in Excel is simple, I think, because I really like to use Excel. So for me, it's simpler, but take your time, practice, especially with your calculator. So 0.05, that's the foreign rate, that's the American rate, times 90 over 360. And then you close the brackets, sorry, the parentheses. And sorry, I think I was making a mistake earlier because their Mexican rate is 0.05 and the American rate is 0.03. So if we fix that mistake, then we're going to get the right number in here. So this is how you solve a problem when you want to calculate the forward rate. And that's how things are going to work from now on. And in the next video, we're going to do another exercise, which is a little bit similar to this, or it's kind of the next thing that comes after this. So I'll see you in the next